So we're looking at our homework list for calories. I'm guessing if you have homework questions, it's there, but maybe I'm wrong. So I want to start by saying, what have you been working on in homework that you want me to do on the board? Okay, somebody go first. Okay.
I had the problem of S6.
So right up above, the chess one. Okay. So there's many versions of an old story about the inventor of the game of chess. One version appears below. On what date will the total grains exceed 3 million? So there's this pattern where, let's see, I'm going to go. The first day, there was 1 grain of rice put on the first square of the chessboard. So, yeah, we're up to 1. The second day, we're doubling that. So we have 2. We had 1 before, so now we're at 3. The third day, we're doubling it again. So 3 and 4 is 7. The fourth day, we're doubling it again. And this gets bigger and bigger and bigger. You could do the pattern. I actually saw one person's paper. They wrote this out, which was, wow, a lot of work. But if you want to cheat, which I will just for the sake of time, then if you click on the helpfully provided link, then this picture tells you how many are on each day. So if you were to make that list, which I know you could, that's just you and your calculator investing in some time, you would see that my ruler is gone. You would see that there's 1 million here, and there's 2 million here, and so it's right on this day when you get the 2 million here, the 1 million here, and some others that you're on more than 3 million. So what day was that? 8 and 8, 16, 17, 18, 19, 20, 21, so day 22. You will get 2 million more. The total will finally go past 3 million. Okay, yes?
I didn't see that board, so would another way to do it be compound interest formula, which, and just applying it for the answers 22, 21, or 21, 22, 23, 24 to see which compound interest?
I wouldn't use compound interest formula. We can talk about that when we get to it. But it's a formula with an exponent.
So how would we do this without the board?
How would you do this without the board? You could make a formula. If you read here, it tells you. I don't want to go into that. Okay. If you wanted to be faster than a calculator, then I could take a moment and introduce what a spreadsheet is, which I don't think we've done in this class, just because that will happen later anyway. Should we do that? Let's do that. So, okay, here's the spreadsheet. Spreadsheets are like a combination of graph paper and calculators. So I can move around with my arrow keys and put in things, right? I can put in numbers and so on. So far it's just like graph paper. I'm writing in the squares. What makes it like a calculator is I could put a formula in. And if I put a formula in on a calculator, then I end with the equal sign. That means I'm done. Tell me the answer. A spreadsheet, it's the opposite. They want to know that this is not a label in the box, but it's going to be a formula. So you start with the equal to tell it that. So if I want to say equals this one times that one, then it does it. What's especially nice are 2 things. One, once I've set it up, if I change things, then it will automatically change it. So if I make this 2 into a 4, then the multiplication changes. So if you're doing the same thing over and over, you have some records in your store of sales or something, and you're just updating them from month to month. Then you could set it up once, make a new copy for the new month, and type in the new numbers, and all the math would happen automatically. So that's one good thing. The other is you can drag things around. So let's actually do this thing. So we had the day, we had the new ones, and we had the total. So 1, 1, 2, 2, and then this one is going to be equals the number above plus the new one. Everyone happy with those two? Okay, now for what day is happening, I'm going to go to the row above and add 1. How many are new? I'll go to this and times 2. It uses the star, because that's what we have on the keyboard. And then this one I'm just going to copy and paste. If I highlight all of them, do you see how in the bottom corner there's like this little small solid box? So I can grab that and drag it down. Well, maybe not with the pen. So drag that down. And it just keeps copying as far as I want. Once I've set up the formulas in one row, it will move everything down. So we didn't drag enough. And there we go. Wow. So we'll do spreadsheets more once we get to personal finance and are working with budgets and things, right? Budgets are a great example of when you want to put in the same kind of numbers each month and see what the totals are and so on. That's a good tool. LCC does offer a basic how to use spreadsheet class. I think it's just a little 1-credit thing. And if you haven't used spreadsheets a lot, that's a great way to get more employable for not much time and money is to take a spreadsheet class. Okay. Anything else about the chessboard problem before we move on? You could find a formula and then sort of guess and check plugging things in. That is an okay way to do it. But that's a hard way for me to talk about right up here in front of you, so. Okay, other homework. Let's see. Okay. Other homework problems people want me to talk about?
That one.
Which one?
With the cubes.
The cubes. Okay. So for the cubes, we want to make a table. Handwriting is not being happy today. This is too crowded. Let me adjust. Okay, now I can write bigger. So the first one had 1 block. The second one has how many? There's one that you can't really see because it's hidden in the middle. And then 4 more, and then 1 on top, so 6. And the third one, we're adding how many? 1, 2, 3, 4, and then up makes 5, right? So we're having 11. Each time we go down a row, we're going plus 5 because we're adding it to each of the 4 base directions and up. So what we're wondering now is if we continue this pattern, what's going to happen? So this plus 5, plus 5, plus 5, we've seen that before. There were a whole bunch like that we did during class the first day. So what's going to happen with that 5 in our formula?
It's going to be n plus 5.
Yeah. Whoops, I wrote y. This should be n. It's not plus. Times. That turns into a multiply. So let's look at the wrong thing. This is 5n. So 5, 10, 15, and so on. What do we have to do as our fudge to make it actually what we want?
The first one.
Add 5.
I don't want to add 5 to here. Then I'd have 10, 15, 20. That would be too big. How do I get from the blue back to these numbers?
Oh, plus.
Minus 4. So the blue ones are too big by 4, right? We don't want those. We want minus 4 as we're going that way. Why are they too big by 4? It's because in the beginning I didn't have the little branches yet. So is it okay now? Yeah. The pattern works for all of these sorts of ones. You see what you're incrementing by, plus 5, plus 5, plus 5. That becomes the multiplying. That's not right. It's not 5, 10, 15. So then you look at the multiplying list and say, what am I needing to add or subtract to make the list I want?
So if we know whatever the difference is between them, we turn that into a multiple.
We can go back and look at our stuff from the first day. So when it was plus 3s, it turned into a 3n. When it was plus 5s, it turned into a 5n.
I think what's confusing me is not the 5n, but the negative 4, the subtract 4. That's where I got confused.
It is a little confusing. You just have to look at the two lists and say, what's the rule that moves me from one list to the other, from the blue list to the black? Okay, all good questions so far. Other homework questions?
I don't know if it's this one or not. It was the one that has to do with interest.
No, we're not at interest yet.
Okay, so that's a different
You're
one.
reading too far ahead.
Okay.
And I haven't even updated the lectures for this term, so
Okay.
it's going to look all funny to you when we actually do it. Okay, let's do a Math 20 review, finish our sort of brain warm-up. We've done those kinds of things. We didn't do fraction division. Okay, any of these somebody want me to do on the board?
Sure, why not? 16 and 14, number 4,
Number 4.
just to double check.
Is that a good one? Anyone have one before number 4? Should we do 3 first? 3? Okay, let's do 3 first and then 4, and then start our new material. Okay, so we want 36 over 930 divided by 0.4 over 93. Well, that's ugly. So the first thing that jumps out of me is I have a decimal in my fraction. Yuck. That's not friendly. So how can I get rid of that decimal? I could just do the fraction division, especially since I have calculators. I can just plug this all in and get an answer, and the decimal doesn't actually scare me if I have a calculator. So I'm pretending I'm not going to use the calculator, in which case jumping right to division is going to be more work. So I'll give you a hint. I really only have two tools as a fraction person. I can do the same thing to both sides of an equation, and I can either multiply or divide by the same thing for the top and bottom of a fraction. Right? Those are like the two things I'm allowed to do to change what's on the board.
So you're saying that if you like multiply both by 10, then it'd be...
Yes. Yes. Great. So if I do a times 10, top and bottom on this fraction, that's going to scoot the decimal point once, right? So now I have 36 over 930 divided by 4 over 930. Everyone okay with that step? Again, if I want to look at what's on the board on my paper and change it, not following a process, but just sort of change something, then my two options are multiply or divide top and bottom of a fraction by the same thing, or do the same thing on both sides of an equation. Those are really the only two tools I have. So that's the one we have to do. Now I'm not doing that. Now I actually want to follow a process. I'm not trying to change what's there. I'm just trying to do the process to simplify it. So how do I divide fractions? I flip the second one and multiply. Okay, I could multiply those and get big numbers, but I'm going to be lazy. So I will cancel the 930, top and bottom, and I'm going to cancel the 36 and the 4. I can divide top and bottom by 4. Multiply across, 9 times 1 is 9. Multiply across the bottom, 1 times 1 is 1. You can be happy you're not in Math 20 where we give you these kinds of problems all the time. Okay, everyone okay with that now that you've seen it done? That's not one that's easy to do. Give it to your random person on the street without a calculator and they will be sad. Okay, greatest common factor of 16 and 14. So there's a few ways to do this. Maybe I'm the kind of person that likes to make lists. What are all the factors of 16? Well, I could do 1 times 16. I could do 2 times 8. 3, 4, sure, 4 times 4, right? There's a kind of official way to do this, by the way. I can say I want all the factors of 16. Remember we talked about the factor trees last class. The factor trees don't give you all the factors. Some wouldn't be in any tree you pick. So that's not the right tool. So instead I'm going to make a horseshoe. I'll say is 1 times 16. I'm going to keep counting down. Does 2 work? Sure. 2 times 8. Does 3 work? No. Does 4 work? Sure. It's 4 times 4. And as soon as I get to the same number on both sides, I'm done. Because if there was some other small number that worked, there'd be some big number it matched up with. So that's sort of the shape you make to check all the factors. Okay, let's also do it with that was 16, so 14. 14 would be even faster. So 1 and 14, does 2 work? Yes. Does 3? No. 4? No. 5? No. 6? No. And I'm back to 7, so I can stop. Okay, so greatest common factor. What's the biggest one on both lists? 2, right? There we go. So that's like the brute force method. I'm just going to find all the factors for both things and take the one that's the biggest on both lists. That's the biggest common factor. I could be clever. This isn't something that you probably need to know in everyday life, but if you wanted to not do so much work of list all the factors and hunt through them, then there is a clever way to do things. I can take my 16 and my 14, and I'll make a factor tree for both of them. Then I'm going to use 2 different colors. You can organize it differently on the page, but I have colors, so I'm spoiled. I'm going to start by circling all the factors they have in common. And that's it, right? Because 14 doesn't have more 2s, and 16 doesn't have any 7s. So, no, these ones are duds. Then everything that I put a green circle around, I multiply not by each other, but just inside one of the factor trees. So in this case, it's just a 2. Let's do one where there's actually more than one thing. So how about if we have 36 and 42? What's the greatest common factor of these? I'll say, well, this is 6 times 6. This is 6 times 7. So they both have a 2 and a 3. There's no 7 on the 36 list. There's no extras 2s or 3s on the 42 list. So what we have is 2 times 3 equals 6. Whoops. That's evens. Does that make sense as a process? Good for fraction reduction if you didn't have a calculator because you were stranded on an island somewhere and needed to reduce fractions. But other than that, not terribly useful. What it is useful for is later on when you're doing algebra, you'll have to do this kind of thinking sometimes with things that aren't numbers, x's and y's. Okay, on to Math 25. Our brains are warmed up. So, our new topic is food preparation, because we finished the old one. Okay. As usual, I'm going to skip over my verbose words, those you can read at home, and talk about things.
I'm sorry, it was the final that I came across that in the homework.
Ah, okay.
That's why I
Perfect. Yeah, let's still wait till we get to it.
Absolutely. Sorry.
Okay. So we're going to scale recipes. Whenever we scale anything, a good tool to use are ratios. So, we'll be careful and use the words right. A ratio is like a fraction, something over something usually. 2 out of 4 dentists recommend this. And ratios are different than fractions, though. So if I had a fraction, then it's always like part out of whole. 3 out of 5 pieces of pie have been eaten. If I flip a fraction over, that's kind of weird. If If you look at the pie, 3 pieces are gone. 5 over 3 doesn't really have anything about that pie. Whereas ratios are comparing numbers. There's a room and there's 8 people in it. 3 of them are right-handed, 5 of them are left-handed. I could write it 3 over 5 or 5 over 3, and as long as I label them correctly, they both make an equal amount of sense. So they work like fractions in the math, in the arithmetic on the paper, but just sort of philosophically they're a little different because they can escape from that part over whole confinement to fractions. When a ratio has words attached to it, we call them rates. You're used to rates all the time, miles per hour, right? Things like that. Nothing fancy or scary there. A proportion is an equation that's a ratio equals a ratio, or a rate equals a rate. So I'm going to start by having you solve a puzzle. Here are 4 different sets of word problems, or actually answered word problems. And for each of them, I'm giving you options that might be or might not be valid proportions. So by yourself or with a neighbor, take a few minutes and tell me for each of the 4 problems which proportions work and which proportions are broken and don't work. I'm not going to stop you yet, but who wants to share something about number 1?
Well, it says Bill can drive 40 miles in 1 hour. So I'm thinking I would put 40 over 1.
Okay, so it would be the red or the green.
Yes. And then you can drive 80 miles in 2 hours, so that would equal 80 over 2.
So you like the red one. What else would people say about the first one?
What was the question? No,
For the ones that aren't red, right? For the blue, green, and the last column is supposed to be brown, so it doesn't work well on the projector. Anyway, so for the blue, green, and brown ones for number 1, are any of those especially good or bad? And we know Misha likes the first one best, which isn't surprising. Is that one also an option? Why do you think it is?
Because the 40 and the 1 hour match up and the 80 and the 2.
Yeah, so these match up, that's good. Does the green one work? Trisha's nodding no, but why?
I guess it just doesn't make sense that way to logically. I don't know how to explain it, I guess. Because those equations are true and those ones aren't. It's not 40 over 1 equals 2 over 8.
Yeah, 40 over 1 we can turn into 40. Any number over 1 is itself. And 2 over 80s, I might not know what that is in my head, but it's not 40. What's another math trick you do with proportions? Process you've been taught. Cross multiply. If I tried that, 40 times 80 isn't the same as 1 times 2. So, yeah, there's something about my math background that definitely tells me that's just lying. It's wrong. How about the last one?
Kind of the same thing.
Same thing. I could say 40 over 80 is a half. The other side is 2. A half isn't 2. Or if I try to cross multiply 40 and 160, those aren't the same. Okay, together we've done number 1. Someone want to come up and use the pen themselves and talk about number 2? And okay, I'm not surprised. So come up here. On the little box here on the top, then if you click on the green or the red, that's kind of highlighty color, you can mimic what I'm doing.
Okay. So, am I doing this or am I asking people what they think?
Whatever you want.
Okay, so what do we think for number 2, everybody? Let's start with the red one. Does it work? No. And it doesn't work because cross multiplying and it doesn't make sense too, right? Okay, so what about the blue?
I think that one works.
If we cross multiply it, it's 36, 36, 36, 36. So it looks good. Does it make sense? All right. So what about the green one? 12 tests over 1 hour, 36 tests over 3 hours. Yes? Okay. And if we cross multiply to double check, 36, 36, it makes sense. And on the brown one?
No.
Okay, why not?
Because 12, it would be 12 and 20 something is not.
Or you could do 3 over 1/3. Either way, it doesn't match up. So this one's no good. Yeah, thank you.
Okay. I'm going to do the third one a different way. That before I got us distracted by calculating things, Mitra was talking about patterns, that we have miles an hour and miles an hour, right? The pattern was the same. Miles an hour, the pattern is the same. For this one, miles an hour, they're opposite. And for this one, miles an hour, and, wrong way. 40 miles goes with 1 hour, 80 miles goes with 2 hours. Now it's even worse. It's like Ghostbusters, we're crossing beams. Right? So we can check without having to do the calculating, without having to find the third or the 3 times 36 and stuff. Just by saying, 220 for a pound, 11 for 5, that looks good. 220 for a pound, 11 for 5, nope, that's not going to work. That one's backwards. 220 for a pound, 11 for 5, that's fine. 220 for a pound, 11 for 5, nope, that's not good. Okay, someone else wants to come up and do number 4? Either way, you can do the style we did above or my arrowy style. No, you had your turn. Someone else gets their achievement. Okay.
Here you go.
If If you want to use orange, since it's not on my cute top bar, you have to go down here and pick orange from the colors. But you don't have to follow my pattern.
Okay. So for the first equation, I don't think it works. Cross multiplication isn't the same. Everybody agree?
Yeah, and the money, day money.
For the second one, we have 175 over 455 equals 260 days over 1 day. That one doesn't really make sense.
One's bigger than one, the other side is less.
Or one's a unit of one, one's a unit of.
So we have $1.75 for over 1 day equals $455 over 260 days. And then 175 over 455 is equivalent to 1 day over 260 days, which
Okay, as far as our brains go, what happened in the very beginning is completely normal. Some people, like this one, where you put one situation on the top, 40 miles for an hour, and another situation on the bottom, 80 miles for 2 hours, and the words line up left and right. But not very many. If your brain does, there's nothing wrong with you. You can always write them this way. That's fine. There's nothing wrong with it. But when I'm doing them on the board, I will always do my proportions this way, just because most people, this looks nicer, the way their brains work. It's not that the math cares, it's just sort of a brain thing. You put one situation on the left, you put another situation on the right, and then the words match top and the words match bottom. So whenever we're looking at a word problem and turning it into a proportion, we know we're doing it right if it's like this top corner. If a situation is on one side, the other situation's on the other side, the words on top match, the words on bottom match. Okay, now we can keep going. It's Amanda, right? Yeah, thank you, Amanda. Okay, so, for example, we're trying to make a shopping list for a restaurant for a few days. We need 1.5 cups of sugar for 12 servings, and the restaurant thinks that they'll want 200 servings of whatever recipe this is during the next few days. So how much sugar should we add to the shopping list for this one recipe's share of the restaurant's shopping? So I'm going to draw the skeleton of my proportion. I'm going to put one situation on one side. I could say 1.5 cups and 12 servings, or I could flip this. It doesn't matter which one is top and which one is bottom. But once I've written it on one side, I know it has to be the same on the other side. Right? Don't cross beams. So what's my other situation? 200 servings, and I have no idea how many cups. That would be my letter. Okay, now I'll pause for the question.
Okay. Well, I was just thinking to myself how I would work that. I would divide 200 by 12, and then times that by whatever.
Mm-hmm.
I would the same way, but isn't that wrong? Isn't there a shortcut? Because I do it the same way, but I think there's a shortcut, right?
Yeah, we're going to do this. You'll see that the calculations we're about to do when we divide and which things we divide will be the same no matter how we go about it. So what I am showing you now is the proportion way because it's really foolproof. When you're taking a test and your brain shuts down, then I'm barely having to think, right? All I've had to do is sort out one situation from the other and make the words line up. So, yes, if you do this a lot, if this is part of your job at the restaurant, then you're probably not going to write a proportion each time. You'll get an intuition and know which ones to multiply and which ones to divide. So that would be faster. But I'm pretending we don't have any intuition yet, and we're doing a test, and our brains are going to shut down. So let's do this the most reliable way. Okay, now we need to cross multiply. Does it matter which diagonal I do first?
You can't times y by 12, so,
Yeah, I can do y times 12. I don't know what it is.
well, yeah.
Does it matter when I have my equal sign here? What goes on one side or what goes on the other? No, there's two things are going to be equal, right? It doesn't matter which I write on the left, which I write on the right, and which I write on the left. So I can pick either part of the x to go left or right. When I'm looking at something in the x, does it matter which of the two things I write first in the something times something? No, right? 2 times 4 and 4 times 2 are the same. It doesn't matter what order I multiply things. So again, it's not because the math cares, it's just my brain. I'm always going to pick the diagonal that has our letter to go on the left-hand side. And I'm always going to pick the letter as the thing that's way on the left. So I'm going to write this one as y times 12. And I'm going to write this one as 1.5 times 200. So 1.5 200s, that'll be 300. How do I get y by itself?
Divided by 12.
Divide by 12. Yeah, we talked about that last time. If something is stuck on with times 12, the opposite is divided by 12. Okay, so calculator time. Again, this is probably more writing than you would do if you did this often on the job. You'd get an intuition of which things to multiply and divide. But this is the put as much on the paper as you can, so there's 0 chance you'll make a mistake. Let's go again through the steps. I pick one situation for one side, the other situation for the other. The words match on the top, the words match on the bottom. I cross multiply. One side is going to multiply together to get a big number. The other side I divide to get y by itself, and I get my answer. So, yeah, we all hit the wrong calculator keys sometimes, but in general, this is as foolproof as you can be. You can do it another way on your homework or on a test, but I'm going to do the foolproof way when I demonstrate things here.
That just seems really confusing.
Then do it your way. That's fine.
So, we're going to divide it because the letter is with 12.
Right, there's a times 12 sort of glued
Right.
onto that.
So we're going to divide that letter by 12.
Basically, you want to get rid of 12 on that one side of the equation so you can get y alone. And so by dividing that side by 12, you get rid of the 12, and then on the other side you can put the 12.
If I have something and then I double it and then I have it, I get back to where I started. If I have something and I have 12 times as many, but then I only get a 12th of them and you get the rest, and I'm still back to where I started. So it's not that I'm doing the y divided by 12, it's that I'm doing the whole side, the y times 12 divided by 12. Whatever works for you in your brain, there will be the 1.5 and the 200 multiplying and the 12 dividing. Whether you think of it as this many per or something like that going on, right? It'll make sense to you. But you can't escape the calculations that happen. This is just one way to rationalize them as, that's why I'm doing the divide by 12. If you're thinking 1.5 cups of sugar per 12 servings, and 12 per means divide, and so on, right? There's going to be a divide by 12 for some reason or another. Okay, oops. Okay, so we could do another one, but let's keep going. We can change our units of measurement. 16 ounces is a pound. You can read more about Roman Empire and history. Parts of a gallon. If you've used parts of a gallon in the kitchen a lot, this is easy. If you haven't, then here's some pictures to help you. There's your gallon. If we chop it in 4, we get quarts, like quarters. That's why they're called quarts. If we take a quart and chop it in half, we get pints. And you could imagine those little pint, like heavy cream containers that are like half as tall as a quart of milk. If we chop the pints in half, we get cups. So the little elementary school milks that are cups are half as high as the heavy cream containers that are pints, which are half as high as the milk things that are quarts in the store. And you could put all the pictures together, say, there's 16 cups in a gallon, or 8 pints in a gallon, or 4 quarts in a gallon. Some of you will put that picture in your notes, and others of you won't need to. Whatever makes sense to you.
That's a good picture.
Why do people say, mind your P's and Q's? We use it these days for manners for little kids. Bildor, mind your P's and Q's. Anyone know the history? Pints and quarts. So back in the olden days, in London, Edwin was racking up his bar bill because it's hard to heat your house. It's easier to meet at the public house where there's the big fire going and everyone stays warm until bedtime. And they can go home and climb under their big sheets and stay warm. So he's there socializing with everyone all winter long. And he gets paid at the end of the month. So as he's drinking, then the bartender is going to put P's and Q's under his name on the wall behind the bar. So mind your P's and Q's means don't rack up too big a bar bill before your monthly payday. Which is not how we use it with little children these days. So there you go. Anyway. Measuring spoons, 3 teaspoons is a tablespoon, 16 tablespoons is a cup. Maybe you know that, maybe you don't. Things to put in your notes if you need to. If you weren't aware, measuring spoons were invented in 1896. There was this big to-do on the East Coast. Fanny Farmer from the Boston Cooking School sort of led the revolution of turning cooking being just putting spoons and mugs and things in a bowl, much more artistic to precise measured, make the formula happen. And some people liked that and some people didn't. So we'll do some examples with that. But all of that is just more proportions. Okay, here's the interesting part. Let's do in class and play with food. Whoops, not the trickiness. There we go. So, if I want to put food in a pot to cook with it, I don't get to use everything I shop for. Sometimes there's bad spots on the food. Sometimes we have skin and pits and all sorts of whatever. So, If I have 100 pounds of avocados, then on average, I'll get 79 pounds of usable stuff for cooking. And the official name for that is the yield percent. So avocados, you get 79% of what you shop for. Your job now is to take my fancy electric scale and my box of my and someone else's produce and measure. Putting towards knives, I brought an apple peeler core if anyone wants to use that. We're going to try and find the percent yield for a couple items of produce. Maybe one each, maybe two each. I'm not sure how many we have in this room until you go in your backpacks. I'm going to pause the recorder because I don't think we need to wait and hear all this noise. And then we're going to come back and share our percent yields. So you're going to need to measure your food twice. You're going to take it, put it on your scale, write it down, trim it so you can eat it, and then weigh the trimmed pieces a second time. Make sense? Okay. So we've done our chopping and weighing and stuff, and somebody give me numbers for one of our fruit, and it was all fruit, no vegetables this class.
For the banana,
Mm-hmm.
we had, it started as 163 grams, and it went down to 114 grams.
Okay, and if you did the division, what was the part divided by whole or whole divided by part? Let's get both.
That's the 70%.
Yeah.
70?
70% to the part one and to the other part.
Divided by part.
Yeah, do them both. I didn't tell you to, but
I'll do it. 63 minus 114 equals 143%.
okay, next fruit.
I did the apple.
Okay,
Total was 134 grams, and the part was 123 grams.
okay,
I think it's like
92%. And 109%.
okay. Pear, also from my tree.
Part.
Also from my tree.
Correct. For me, for whole over whole part, I got 1.045.
So 105 basically.
Yeah.
Okay.
Then 95% afterwards.
And what were the
Oh. The whole was 91 grams per part. It was each side.
okay. And the plum?
That was 39 grams.
and then the part was 37, because we just took out the part.
And I did not do that.
Divided by 37. The one on the right is 105. And 37 divided by 39 is 95.
Okay. Same as that pear. Okay, so a few things to comment on. One, these are somewhat useful, right? Not all pears are identical, not all apples are identical, and so on. And so, like most of the things in our class, we're going to have an official table of percent yields that we'll use for our problems, so I can say if you got the math right or not. But if you go to work in a restaurant or a catering service and they have a different set of numbers, then trust their numbers. And different chefs will be different. how you trim things. Right? No one decided to use the apple peeler corer machine, but that would be a different way of doing it than the cutting board. So treat these with a grain of salt, that they're meaningful numbers, but that doesn't mean they're exact just because they're meaningful. Second, these two columns are both great. This one answers one question. I went to the store, I bought a banana, how much of the banana makes it into my banana bread? 70% does. This column is also great. It answers a different question. I want to buy 5 pounds of bananas. I want to have 5 pounds of banana in my banana bread. If I go to the store, how much more do I need to buy so that after I peel them, I still have the 5 pounds? I need to buy 143% of what the recipe says. So these are both meaningful, good, real-life numbers. Somebody, when they were talking about this culinary history, had to pick one of the columns. Are we going to pick yield percent is how much you have left after you peel it, or how much you're going to shop extra for so that you have enough in your recipe? And just as an artifact of history, they picked this column. Yield percent goes down when you're shopping to what actually makes it in the recipe. Okay, so here are our yield percents. And of course, there's a lot more than that as far as types of produce in the world, but this will be enough to give us a variety of problems so we're not working with avocados all the time. If you want to try it with meats, you can think of it in the same way, because you have to trim meats. But we're not going to talk about that at all. That's really complicated. How you cook the meat, the kind of recipe, how the chef works, these numbers get even fuzzier than they are for produce. So we're just going to stick with the produce. All of this is, of course, if you're actually working at a restaurant or a catering service, calculated. Your computer will do all of the work for you. So you are jumping through this hoop to show not only that you understand what's happening in the background on the computer, but if you could do this math, then whatever kind of math you actually have to do on the job, you can also do. Right? It is both real and fake to make you do this. Okay. So again, we can look at the number and say, I buy 100, I'm going to multiply by 0.78, because it says 78% for potatoes. I get 78 pounds that I get to use in the recipe. As written, this goes down, it shrinks the amount you shop for to get what goes in the pot. How do I do it the other way? I want 100 pounds of potatoes in my pot. How much should I shop for? What am I going to do? I can't do it times 0.78. That's going to make it smaller. Divide, yeah. So if I want to use these backwards, then I divide instead of multiply, and they get bigger. And that's what we'll mostly do, because that's the interesting question, is how much more do I have to shop for? That's sort of more practical, too. I'm planning what my restaurant is going to prepare for the next week or so, knowing my customers' habits. What do I get to shop for so that I can make all these foods? Okay, we don't have much time, but we can do an example. First, clever picture. When you have a number less than 1, like all these scale factors, or like the exercise calories per pound per minute things, if you multiply by a small decimal, you shrink the thing. If you divide by a small decimal, you make it bigger. So if no one's shown you that before, then there you go, in color. Okay, so here's our great one to do as our grand finale for the day. With only one grand finale example problem, I'm not going to expect you to really start this as homework over the weekend, but in theory, we're done. This is all there is to it. You could do more if the weekend is the good time for you to do homework. But if this is kind of shaky and you want to wait till we do a whole bunch more of these next week, I don't blame you. Okay. A recipe makes 28 servings, it calls for 5 pounds of carrots. How many pounds of carrots should you purchase if you're scaling up the recipe? Now we're making a big dinner for 105 servings. And also, if carrots cost 75 cents a pound, what will the carrot part of the recipe cost? What number don't we have on the board yet? The yield percent for carrots. So I have to go back. Here. Come on. There we go. There's carrots. Yield percent for carrots. So there we go. Carrots are 81%. Okay, now we're ready to start. So first, we're going to scale the recipe. As before, I'm going to use a proportion. If that doesn't make sense to you, like Mitra, then do it your way. That's also great. We're going to wind up doing the same, multiplying and dividing.
Well, I'm trying it the way you're showing us, so I can at least try to learn that way.
If it only slows you down, then don't. There's no right or wrong, as long as your method is consistent and gets the right answer. So there's the situation. 28 servings is 5 pounds. I need the other situation on the other side, 105 servings, and some unknown number of pounds. Servings on the top matches, pounds on the bottom matches. You could flip everything, but make sure they match however you write it. Okay. Y times 28. Fine. Now I'm getting 18.75, so I'm going to round up because I'm shopping. I don't want to risk getting too little of something. So just because I'm making more of the recipe, I need 19 pounds of carrots. Everyone okay with me? Your math agreed with mine? I didn't hit anything wrong? Okay, part B. Is the yield percent. So I have my 19 pounds. What do I do with that 81?
Divide it by 0.8.
Divide it by 0.81. And again, 23.45, I'm going to round up. Normally with 0.45, I'd round down. But just because of the context, I'm shopping. I don't want to wind up with too little. I'm going to buy a little bit more. If you rounded down to 23, that could be correct also.
So instead of rounding on each step, I just rounded the last one.
That's fine.
Does that make a difference?
It will, but not a big deal.
Okay, I'll still be able to figure out.
Yeah, your restaurant will still do great.
So if I want doing it my way, it wound up being approximately 23 pounds.
Okay, yeah.
Can I ask you a question again?
Okay, yes. And then the last step is the cost. So we had that, whatever, 23, 24 pounds, depending on how much you've rounded and what way. Oops, I should be consistent on the page, though. And now we're going to multiply it by the 75 cents per pound. So I get $18. if I didn't round it, let's see what I would get. So 525 divided by 28, and then divided by 0.81, and then times 0.75. So I had $17.36 was my unrounded one. So they're both correct. Right? It's just sort of real life, what you're going to do, how much you want to risk not having enough carrots. Will anyone notice? So there we go. Let's see. We've done calories and metabolism. We had questions on any of that. What did we do in the beginning of the?
We did a factory.
We did a factoring. We did a pattern.
We did the chessboard.
That was patterns.
Spreadsheet.
Let's see. Yeah, we didn't do any of either, did we? Okay, yeah, so both calories and metabolism can be due a week from today. Anyone need another book before you run away for the weekend?
So the calories and patterns.
Have a good weekend. Anyone want more apples?
Thanks for bringing them.
Are they 92% worm-free?
I think all of them are, but if we're just heading home, we'll have to leave them at home.
Okay.
It will also be our job to refill the dehydrator, right?
See you on Monday. Tomorrow, teacher.
I just wanted to say, maybe where your kid could hear how I turn this class into something that's better than it would be if it was just numbers. It's real life. I tested it in 95, so I thought this would be a breeze, but I'm actually learning and working. So how to handle math, and your dad does that for us, so it's pretty cool.
It shouldn't be a hard class, but it shouldn't be boring either.
Yeah.
Okay, we're not going quite yet. I have to have my computer work for a few minutes.
Why?
Why? Because they get the slides and the video. You watch YouTube. Did you know we're on YouTube now?
Really?
Yes. So save as.
The next book report, is it the same parameters? I don't remember.
Yes, they are all the same.
Okay.
The only difference is that the very end for factfulness, you were supposed to pick two things and apply them to a fictitious business.
Right.
And now you're going to pick two things and apply them to that book.
Oh, gotcha. Okay.
Did that author do good or bad with the gap instinct or the fear instinct or something like that?
Okay.
Okay, let's make sure.
Thank you. Have a good weekend.
You too.
Bye.
Are you feeling better about things?
What's that?
Are you feeling better about things after?
Yeah. I had a really bad sinus infection last week and I just was in a fog. So I think I'm gonna be okay. I know I am. I'm just like, I'm a perfectionist. So if I don't get an A in everything.
That's why I'm making you watch Mind Walk if you're willing. 'Cause it's old. There's new developments in holistic thinking since then. It's going to talk about Cartesian and systems theory, and there's more steps after that that have been invented since the movie was made. So I'll bring it all together if you ever finish. But if you don't care, that's fine too.
Well, my son wants to watch it. He's very philosophical. He was already drawn in immediately. He's pretty brilliant. He's over at U of O. I have college grads and yeah, cool. So maybe I'll grab